take a look at this problem and see what we can figure out. So we have a railroad problem from homework 2, homework B, and it says when a car leaves its home railroad, it becomes part of the national pool. The rules governing use of the pool cars are designed to eventually return the car home. Particular railroad found that each month 17% left to join the national pool and 46% um, of the national pool returned back home. Okay, so if you want, you could think that this is home and this is the national pool or something. They didn't give me what the probability of staying home is, but they did give me the probability of going into the pool, which was 17%. And then I don't think they gave me what's the probability of staying in the pool, but they did give me the probability of returning back home. Okay. Now I claim, let's see if my calculator claims the same thing, that all of this has to add up to 100%, or each one. So for instance, if we have the 17%, then this has to be 83% that it just stays in home. Okay. And then with the 46%, you know, 1 minus 6. Whoops, not like that. I guess you can't. 1 minus 0.46 is 54%. So I think that's point. Okay, so we have an idea of what's going on. Now we can make Markov chain with this. So we have 3, 17, we have 54%, we have 46%. Okay, but they want in the long run. They don't want just one transition. They don't want just two transitions. They want long term. Well, I don't know how to do that because they didn't tell me how. So in the long term, there's some number, which is the probability that in the long term, they just stay at home. And there's some probability that they go to the national pool in the long term. How do you solve for these? Well, I don't know. Let's see what we can do. So we have row times column. So you have 0.83a plus 0.46b equals a, equals a. And then the other row and column, you would have 0.17a plus 0.54b equals b. This is the second equation. Okay, but that still doesn't solve for what a and b are. It just gives me another problem to solve. So I need to subtract a on both sides. I need to get everybody on the same side. So this is going to be 1 minus, I really should say it's going to be 0.83 minus 1. So what is that? What is point? I think it's 17, right? So you have 0.83 minus 1. Yeah, that's 17%. So we have negative 0.17a plus 0.46b. Remember, b was the national pool, equals 0. Okay, let's do the same thing for the other one. So we're going to subtract 1 on both sides, subtract b on both sides. And this stays the same. But what's going to happen? You're going to have 54 minus 1. You're going to have negative 46b equals 0. Well, uh-oh. We have two equations, two unknowns, but they're the same equation. So we're missing information. Missing info. So we don't have enough information to solve with just these two equations. So what were we not told, or what do we know they just didn't tell us? Sometimes people call this normalize. X well, let's not do X because we did, sorry. A plus B equals 1, right? Now, why do I say A plus B equals 1? Well, I know the probability has to equal 1. If you add these things up, they have to equal 1. So what does it equal? Well, I don't know what it equals, but I know that if you add them together, it equals 1. I have two equations, two unknowns, and then I need to add this equation in. So now I think I can convert this all into just one idea. Negative 0.17, 0.46 equals 0, and then we have 1, 1, 1. Let's make an augmented matrix. So if I plug this matrix in my calculator, or I can solve it by hand, this will tell me what I want to know. What was it I wanted to know? Let's double check we understand what it is that we are looking for before we solve it. What percentage of boxcars, excuse me, are at home? So this is going to give me two different numbers. I want the first one, the home version. Okay, I want the first number, or it'd be the top number here. That's what I want. Okay, save a picture of that. I'm going to have to move over to some kind of calculator to do this. Okay, I wrote down just what we did so I can look at it. Oops. So this is negative 0.17, and that was 0.46, and that's 0, and this is 1, 1, 1. Okay, enter. Now we want it to reduce that, so reduce A. Now this number right here, that is the probability that the train stays. Okay, so 73%. 73%. We see we got more than what they asked, but that's the answer. Okay, so let me save a picture of that too. All right, so we found that 73% stay home in the long run. In the long run. Okay, I hope that helps. Reach out if you still have any